I'm going to describe the Lineweaver-Burke plots for Michaelis, Menten, enzyme kinetics. And I'll use the simulation I've given a link here to show what the plots look like. And what we do is we plot the 1 over the rate. So R sub S, let's look at the kinetics. We have an enzyme reacting with a substrate to form a complex. This complex can dissociate back the enzyme and the substrate, or it can react to form a product and give us back the enzyme. So the reaction rate, and this is derived in other screencasts, so I won't do that here. And then this is the rate of product formation, and of course that means it's a negative of the rate that the substrate is used up. So minus RS is a positive number. So the inverse we can see it's a straight line. Here's the intercept. And then the slope, Km over V max. Km is a constant related to this dissociation, this first two reactions. And V max is the maximum rate we can get. So here we've added two more steps, namely inhibitor I that can also react with the enzyme to form a complex which is not active. And that complex can dissociate back to the inhibitor and the enzyme. So the rate of reaction now includes the concentration inhibitor here. And then we look at the inverse rate, the Lineweaver-Burke plot. We can see the intercept is the same, but the slope is different, and the slope is larger by this number, which is a number greater than 1. So if we look at the actual plots then, they're both straight lines, plotting 1 over the substrate concentration versus 1 over the rate. So as the substrate concentration increases, the rate increases, so 1 over the rate decreases. If we have an inhibitor, well, the rate's slower, so 1 over the rate is higher. So this is the reaction, the rate when we have an inhibitor, and this is one where there's no inhibitor. And this inhibition is one of over several types. This is called competitive inhibition. And let's look at a few others. So let's look at what's called uncompetitive or anti-competitive inhibition. And in this case, we have an inhibitor that reacts with the enzyme substrate complex to form a complex that's inactive. And this complex can also dissociate back to the inhibitor. The rate expression then is shown here, and the inverse, we see that the slope is the same as we had when there was no inhibitor, but the intercept has changed. So if we look at the plot, we see that the slope is the same. This is the plot with the inhibitor. This is the plot without the inhibitor. So the slope is the same. So we can see an inhibitor decreases the rate, which increases 1 over the rate. Well, let's look at another type of inhibition. This inhibition is referred to as non-competitive or mixed inhibition. And this means it combines both things. We have the enzyme that can react with the inhibitor to form an inactive complex. It also can dissociate back. And the inhibitor can interact with the enzyme substrate complex, or the enzyme inhibitor complex can interact with the substrate in the case we make inactive, right? So this is inactive and this is inactive. Same thing here, these are inactive. So here's the rate expression. Now we look at the linear plot. We see the slope is higher than with no inhibition, and the intercept is also. So if we were to look at the plots, and we've changed the scale here from previous just to show the difference. This is the plot with no inhibition. This is the plot with the mixed inhibition. We see we've changed the intercept, and we've also changed the slope. Well, let's look at the final type of inhibition, and that's where the substrate itself inhibits the rate. So the substrate reacts with the enzyme substrate complex, and it makes something that's inactive. The rate expression here looks like this, and now if I try to make a plot that's linear, we see that the intercept depends on the substrate concentration. And that means when we look at the plot, it's not going to be linear. And notice then, as the substrate concentration increases, moving to the left, 1 over the rate increases rather dramatically. Namely, the rate decreases as the substrate is inhibiting the reaction by reacting with that enzyme substrate complex.